Hello everyone. Welcome to the Tele-Online Education Program of the Department of School Education. I'm really happy to be here with you. This is my first class for Class 8. I'll be teaching you mathematics. So during this time of lockdown, I hope you are ready to go for some extra mile, go through some extra mile to learn more. It's been more than a month since we have been under lockdown, and I'm sure we have all been laid back. Now, let's go back to school at home. So, the first chapter that I'll be dealing with is from NCERT textbook of Mathematics, Class 8. The name of the chapter is Understanding Quadrilaterals. It's chapter number 3, Understanding Quadrilaterals. If you have the textbook with me, if you have the textbook with you, please turn to page number 37. Now, when we talk about quadrilaterals, the first thing that you should know, you and I should know, is that the first thing that we have to know is about polygon. Now, what exactly is a polygon? Polygon, it is a simple closed curve made up of only line segments. Now, let me write the definition here. A polygon is a simple closed curve made up of only line segments. Now, when we talk about a simple closed curve, now before we go there, let's discuss about a curve. A curve can be anything that you drew, any shape. It can be any shape. Now, this curve is something that you draw without lifting your pen. When you draw something like this, you are doing it without lifting your pen. Now, these curves that I've drawn, they are all called simple curves. Now, if you look at these two are called simple closed curve because they are closed in all the ends. Now, a simple closed curve made up of only line segments. Line segments, you already know what line segments are. Now look here, when you look at all this, you see this with two line segments, but we know that this is open. So this is not a closed figure. If you look at this is not a line segment. If you look at this, it is a circle, it has no line segments. Now when you come to this, if you look at this, it has line segments. We can see that it has 1, 2, 3, 4. 4 sides, that means 4 line segments. Now, this is called a polygon. The polygon can be of many sides. It can be of 3 or more sides. Now, let me show you some examples of what polygons really are. Now, if you look at this chart that I have with me here, there are some few types of polygons that I have listed here. You can see a triangle, a quadrilateral, a pentagon, a hexagon, a heptagon, an octagon, a nonagon, and a decagon. We have more. Now, they are classified like this according to the number of sides. The first one is of 3 sides, the second one is of 4 sides, the third one, 5 sides. So accordingly, they are named. Now, in this chapter, we're going to deal mainly with quadrilaterals. Four sides, quadrilaterals. Now, when we look at the name quadrilateral, it is derived from a Latin word. Quadri means 4, and latus meaning sides. So, quadrilateral simply means 4 sides. I hope you have understood that. Now, after we understand what a polygon is, we will try to learn more about its characteristics. Now, let me draw a simple polygon. Let's say a square Now, I'll mark these as A, B, C, D. 4 vertices. A, B, C, D. Or we can call them endpoints. Now, the next topic that we're going to learn about are diagonals. Diagonals of a polygon. These diagonals are, they are simple line segments, they are simple line segments that joins two non-consecutive points or vertices. Now if you look here, A and B, they are sides. They cannot be called as diagonals. But if you look at A and C, they are non-consecutive. A, B, they are consecutive. A, D, they are consecutive. So you cannot call this as diagonals. But when we join A with C, this particular line becomes your diagonal. Now if you join these 2 points, they are non-consecutive vertices. These points are called your vertices. Similarly, B and D can be joined in this manner. So in a polygon of 4 sides, we have 1, 2 diagonals. The next thing that we have to know about polygons are, the polygon has 2 parts. One is the interior, the other is called exterior. The word itself says interior means inside, exterior means outside of the polygon, outside of these lines. Now, interior has a boundary, A, B, C, D, a boundary. Exterior is limitless. It has no boundaries, all right? Now, the next characteristic of a polygon. Polygons are of 4 types. First one is convex, second, concave, third, regular polygon, and fourth, irregular polygon. Now, we may and may not have come across these terms. Let's look at them one by one. Convex. Convex are those polygons whose diagonals, we have learned, whose diagonals fall inside, in the interior of the polygon. All right? And concave is just the opposite. There are some polygons that look like this. These are made up of line segments. We have 1, 2, 3, 4. Now, if you want to draw a diagonal for this, 2 non-consecutive points, we cannot join these 2 because they are already sides. Now, if you want to make a diagonal for this, the diagonal is formed outside the closed figure. These are called concave polygons. Now, what about regular? Regular means equal sides and equal angles. Any simple closed curve with equal sides and equal angles are called regular polygons. Now, for example, we have a square. This side is equal, this side is equal, this side is equal, and this side is equal. We have all the angles at 90 degrees, so this can be called a regular polygon. Irregular polygon is just the opposite. No equal sides and angles. Now, there can be cases where we draw something like this. No sides are equal. At the same time, there can be cases where 2 sides are equal. These are equal, but these 2 are different. Now, these types of polygons are called irregular polygons. the next thing that we'll be learning about is the angle sum property of polygons. Now, we have already seen that a triangle is a polygon. It is made up of line segments. It has 3 sides, 1, 2, 3. Now, we have already learned about the angle sum property of a triangle. When you add up all the sides, let's mark them A, B, C. If you add angle A plus angle B plus angle C, it has been proved that you should get 180 degree. This is the angle sum property of a triangle. Angle sum property of a triangle. Now, you take any type of triangle. You can take any type of triangle. When you add the interior angles, when you add all the 3 interior angles, you will definitely get 180, no matter what. So, this is the angle sum property of a triangle. Now, when we talk about quadrilaterals, let me take a simple quadrilateral. It can be any quadrilateral with 4 sides. We have 4 angles here. Now, what we're going to do is, before that, we will draw a diagonal. Let me mark this A, B, C, D. When I draw a diagonal from A to C, we can see that 2 triangles are formed. The first one is triangle ADC, and the next one is triangle ABC. Now, if you want to get the total angle, internal angle of this quadrilateral, what we're going to do is we're going to add the angles of these 2, We're going to add the angles of these 2 triangles. Now, we already know from angle sum property of a triangle that sum of 3 angles is always equal to 180 degree. This also the same thing, 180 degree. When you add this, you get 0, 0, 0, 8, 8, 16, 1 in hand. You get 360 degree. So this is the angle sum property of a quadrilateral. As already discussed, quadrilateral means 4 sides. Quadri 4 and lateral or lattice means sides. Okay, with that we have come to the end of the explanation part where we understood the concepts of polygon and quadrilaterals and angle sum properties. Now let's look at some exercises. Now if you can please turn with me to page number 41, exercise 3.1. We will try solving some problems here. Due to limited time, maybe I will not be able to solve everything, but I will try my best. I will try to do justice here. Anyway, let's start with the first exercise. Exercise 3.1. The first question is, given here are some figures. Now, since there are lots of drawings, I will not be drawing it on the board. The first question, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, sorry. 8 figures here. Now, basing on these 8 figures, they have posed a few questions below. So I want you to carefully look at the questions on your textbook. Now let me read the rest of the question. Classify each of them on the basis of the following. A, simple curve. You know, in this picture, they want us to identify simple curve. Simple curve means, I already told you, you draw a line or a circle without lifting your pen once. So we can see that number 1 is a simple curve, number 2 is a simple curve, number 3 we have 2 circles, so this is not a simple curve. Number 4, this is a complicated figure, we cannot call it a simple curve. Number 5 is a simple curve. Number 6 is a simple curve. Number 7 is a simple curve. Number 8 is also not a simple curve. So let me write down the answers. Question A, answer 1, 2, 5, 6, 7. These are all simple curves. And for the second part, B, simple closed curve. We can see that 1, 2 are simple closed curve. We have already come across this. 3 and 4 are not simple curves. 5 is a simple closed curve. 6 and 7 are also simple closed curve. The answer is same as question A. Similarly, for C, we have to find polygons. Polygons are line segments. Now, are made up of line segments. They are simple closed curves. So look at the first figure. We have line segments. So 1 is a simple closed curve with line segments. So it is a polygon. 2 is a polygon. The rest, we know that they are not made up of line segments. So only 1 and 2 are polygons. One and 2. Convex polygon, as I've already told you, we have 2 polygons here in the question. One is this and one is this. Now, if you want to make a diagonal here, the diagonal comes in the exterior of the polygon. So this is not a convex polygon. When you draw polygons here, diagonals in this polygon, all the diagonals are in the interior. So this number 2 is a convex polygon. Similarly, number D. Similarly for E, among the 2, this is a concave polygon. So this figure is your number 1. So 1 is a concave polygon. Let's move on to the next question. I'll just read it out. Question number 2. Question number 2, how many diagonals does each of the following have? A, how many diagonals does each of the following have? A, convex quadrilateral. Now look at the first question, convex quadrilateral. We have already discussed quadrilateral is any shape with 4 sides. Convex means the diagonals should be inside. Now, when you draw diagonals here, how many diagonals can you see? Let me mark them A, B, C, D. Now the first is AC. AC is one diagonal and BD is another diagonal. So we have 2 diagonals. Similarly, for B, a regular hexagon. Now the word regular has come. That means all the sides are equal. In a regular hexagon, we have 9 diagonals. 9 diagonals. Now look at the last one. See? A triangle. A triangle. Do you think any diagonal can be formed here? See, we have 1, 2, 3. 3 vertices. All vertices are sides. There's no way that you can draw a diagonal. So we have 0 diagonals. Now, let's go to question number 4. I'll quickly draw this. Now we have this question, in question number 4, this table is given. Now they're asking us examine the table. Each figure is divided into triangles and sums of the angles deduced from that. Now we have this figure given. They're asking us, what can you say about the looking after studying this, you have to answer, what can you say about the angle sum of a convex polygon with number of sides? The first is 7 sides. Now, they have given us examples of 3, 4, 5, 6. Now, before we go to this, we have to know that there is one formula for finding the internal angle sum of the polygons of polygons. Okay, let me rephrase that. Before we go there, we have to know a formula with which we will find the angle sum of polygons. Angle sum of polygons. Now, we have already learned about triangle. It is 180. For a quadrilateral, 4 sides, it's given 4 minus 2 into 180. If you look at this carefully, there are 5 sides. It is given 5 minus 2 into 180. If you look at this, it is given 6 sides, so 6 minus 2. We can see that minus 2 into 180 is repeating everywhere. Now, similarly, in place of this 4, 5, 6, what I'm going to do is I'm going to put n. N will show, denote the number of sides. So n minus 2 into 180 degree. Kindly note this. Now, with this formula, we can find the interior angle sum of polygons of any number of sides. It can be 1,000 sides, it can be 100 sides. So as long as you have this particular formula, you can easily find the angle sum of the polygons. Now this is given as 7. We know that n minus 2 into 180 will give you the angle sum of this polygon. So we will take n as 7 minus 2 into 180 degree. N will be 7, minus 2 will remain same, into 180. So when you take this, 7 minus 2 is 5. When you multiply this, 5 into 0, 0, 5 into 8, 40, 5 into 1, 5 plus 9, 900. So using this formula, you're getting 900 as the angle sum of this polygon with 7 sides. Similarly, for B, C, you can try at home. D is nothing but the formula, n sides. Let's move on to the next question. Let's skip to question number 6. Find the angle measure x in following figures. The first one is given as 120 degree x, 130 degree and 50 degree A. This is the first figure that they have given us. Now we have to find the angle measure of this particular quadrilateral. It is 4-sided, so we will find the quadrilateral, angle of the quadrilateral. Now we have already learned that we add this, this, this and this. If you add all the 4 angles, you should get 360 degree. Now this is because of angle sum property of quadrilaterals. Now, simple addition, 50 plus 130 is 180, 180 plus 120 is 300. So implies this 300 will be shifted to the right, x will remain as it is, 360 degree minus, this will come this side. It is plus 300. If you shift the side, it will become minus 300. So we have x is equal to 60. So this is the first question. I hope it is clear. It is simple angle sum property of a quadrilateral of 4 sides. We add them up, we get 300. X cannot be added, so we keep x as it is. X we take on one side, the numbers we take on the other. We solve, we subtract them, we get x is equal to 60 degree. Now let's go on to the next question. Now let's look at question C. It has an interesting figure. Now, this is the angle given. This is the figure given in the question. We have to find x. We have to find x. So before we directly, there's no way that we can directly find x here. So what we're going to do is we're going to look for some ways through which we can finally reach x, the value of x. So what we're going to do is we're going to look at these two angles first. Let this be 1, let this be 2. Let this be angle 1, let this be angle 2. Now, if you look at angle 1 and 70, we can clearly understand that they are forming a linear pair. Linear pair. That means angle 1 plus 70 degrees should give you 180 degree because they are forming a linear pair. Or in simple words, a straight line is 180 degree. So this, when you join these two, it will become a straight line. It should give you 180 degree. Now with this, we can find angle 1. Angle 1 is equal to shift plus 70 to the right side will become minus 70. Therefore, angle 1 is 110. Similarly, for angle 2, we can see that, angle 2 plus 60 degree should give you 180 because it is a linear pair. So angle 2 is equal to 180 minus 60. Therefore, angle 2 is 120 degree. Now we know angle, we know angle 1 and angle 2. So after that, we're going to proceed to we're going to proceed with this. There are 1, 2, 3, 4, 5. There are 5 sides. 5 sides means to find the angle sum property. Angle sum property. We are going to add this 30x to angle 1 and x. So what we're going to do is 30 degree plus x plus, now we know angle 2 is 120 degree. So angle 2 is 120. Then angle 1 is 110. Oh, sorry, before we go here. So sorry. Before we go here, we're going to find out the total angle, the total interior angle. So what we're going to do is n minus 2 into 180. There are 5 sides, so n will become 5. 2 into 180. We get 3 into 180. We get 540 degree. That means the total angle sum of this particular figure is 540 degrees. Now, if you're done with this, let me rub this. After that, finally, to find x, what we're going to do is we're going to add up all the sides. We got this 120, we got this 110. So 110 degree plus x. 30 plus x plus 110 plus 120 plus 110 plus x. So we get, it should get, oh, sorry. We got 540, so it should be 540. Now, you add up all this, you get 150, 260 degree plus 2x, so 2x, 540. Now, this 2x will stay as it is, 260 will be shifted. So, when we subtract this, we get 0, 0. 14 minus 6 is 8, 2. Now finally, x, 2, this is multiply here, when it go on the other side, it will become divide. So we can cancel, 2 into 1 is 2, 2 into 1 is 2, 2 into 4 is 8, 2 into 0 is 0. Therefore, x is 140. I hope this is clear. This is how we find the value of x. With that, we will try to solve one more problem. This will be an assignment for you. I'm going to give you an idea of how you're going to go about it. The next question, x, 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 x. So they have given us all the angles as x. We have to find the total angle first, then similarly we will, similar as the previous question, we'll come back to this. First you have to find the total angle, first step. Second, 1, 2, 3, 4, 5, 5. So you're going to add all these 5 axes, 5x, and whatever you get here, you will insert here. Whatever answer you're getting here, you'll insert here. You solve this and try this at home. Now today, with this, I will end here. Today we have learned about polygons, its diagonals, its interior and exterior part, 4 types of polygons, that is convex, concave, regular and irregular, and finally the angle sum property of polygons, which is we have looked at one triangle, which is 180 degree. For a quadrilateral, it is 360 degree. And finally, for different types of polygons with different numbers of sides, we will be using this particular formula. So with this, I'll wind up here, and I look forward to meeting you in the next class.